Good morning, everyone. Welcome to Urja session. This is multi-threading, and we are in deadlock conditions in multi-threading in the topic. Previously, we have discussed and write this program. Maybe there may be chance of an understanding issue. So again, I'm going to explain this deadlock condition. Now try to observe this program carefully. Okay? I am removing this synchronous keyword first. Try to observe. I am removing this synchronous keyword from here, so that you can understand the program, and then we will start. Okay. Now guys, observe what is the this program actually meant for. The program, I have created one test class and one another class, test2 class. This is having some method m1a and m2 method, right? This is having one m1b method and m2 method, right? What is our multi-threading concept? Multi-threading concept means there are two threads or more threads which are working parallelly, right? One by one or parallelly, right? So here deadlock coming because of synchronized keyword. Means one thread is there. Thread is nothing but a program in background. If you are writing our program, even though our main method is running, main method is running. Why main method is running? Because main thread is there. Main thread is which is going to trigger this main method. Main method is also run by whom? Main thread. There is a difference between main method and main thread, right? Now try to observe what we are trying to do. We are having one main method. It is simple core Java logic only. Nothing is there. Now observe. Why I am using this thread dot sleep? I will show you that. For example, I comment this line. Okay? I comment this. Let me comment this part first. Try catch. I comment this part. Okay? Similarly, I can comment this part. What is the use of this thread sleep? I will tell you. Please read, listen to me carefully and observe my each and every step. So there is nothing till now. There is no, just think this is normal method, right? This is one main. This is one method, right? It is going to take what? Let me add touchpad as well. So that I can draw my diagram clearly. Now, now try to observe. It is not like a normal method. Na? This M1 method is like a normal method, right? It is expecting what? Test2 class object. Where is test2 class? This is our test2 class object. Whenever this method is going to call, simple Java, core Java, nothing is there. Unless and until I will explain you, this is normal method. This is also normal method. Na? When M2 will be called, this will be printed. When this M1A called, this will be printed, right? Simple. Similarly, M1B is what? Normal method. But this is expecting what? Test class object. So we need to pass this test class object. Then this method will be called, this will be printed. Similarly, M2 method is there. When it is called, it is will be printed. Now, involving multi concept here. Now we are involving multi-thread and then deadlock condition because of synchronous keyword. Try to observe now. So to understand deadlock condition, we need to understand how we are calling this method, why I am taking this another class, and why I am taking this logic instead of here. Because tell me guys, main method is what? Main method is what? Static area. Na? Simple. Main method is static area. And whenever we are creating object, can we call the object reference from static area? No, we cannot. Simple, right? So, but we can call constructor, right? Now, so that's the reason I created one constructor here inside new test deadlock. So what is going to happen? This is the constructor now. This is the constructor. This is going to call. This constructor is going to call. This is our first part. This is our first part. Hope you are good. This is our first part. Now, what I am trying to do is I am defining one thread, test deadlock implement runnable. We can implement thread by extend keyword and implement runnable. So by implement runnable is the better approach because it is allowing us, we can extend some more class if required in our requirement. So implement runnable is the better approach. This is how we are defining our thread. This part also you are good, I believe. Okay. Now, why I created object? I need to call this method now. I need to call this method. I need to call this method. This method is available in this class. So that's the reason I need to take an object reference. Then we can call this method. Okay. I created a constructor. I created the class. Now I need to define the thread na child thread. Main method is called by main thread. Perfectly fine. But I need to create one child thread. How we can create child thread? We need to create a thread class object. Thread equal to new thread, and I'm passing current class object. Okay. Now thread dot start. Always we need to call run method. Na? Always we need to call run method. Means when multi-threading concept will come, when more than one thread is there. Multi means more than one. So already main method one thread is there. So I am creating one more child thread. Means now how many threads are there? Two threads are there. When I am calling thread dot start, how many threads are there? Two threads are there. No. Thread dot start will call internally what? Run method. Right? So this is called by child thread. That's why I marked as child thread. And this will be called by main thread. Now there are two threads are working together. Now we have involved multi-threading concept. Now observe. Now observe. I'm clearing the drawing. I clear the drawing. Till now you are good. Now we one by one we will add synchronized keyword. Synchronize to get synchronized keyword. To call the synchronized concept to understand the deadlock condition. Now observe. we can call. See, this is the synchronized area. Now this is synchronized area. Now try to observe. Synchronize. Take this here. First I will use synchronized keyword here in M1B and M1A. Paste here. Paste here. Save this. Save this. We are using synchronized keyword, but till now all methods are not synchronized. These methods are not synchronized. Right? Why I am using this thread.slip? Why I am using thread.slip? Because there are two threads. Slip method, what it will do? Slip method will give opportunity to another thread. See, a thread operation can be done in millisecond, nanosecond, microsecond, picosecond. But we are giving 3-second time. What does this mean? Whenever this thread will run, the line number will come. The whatever this method that will slip, and another thread will get the advantage to run. When thread will slip, this thread will come. When this thread will run this logic, then what will happen? This thread will slip. We are making both the main thread and child thread. At some time it should slip. And child thread should work. Main thread will slip. That way, both the thread can complete their functionality. Na? Both thread can able to complete the functionality. The moment I will add sync keyword, it will wait. Both the thread will wait for each other. Now I use this synchronized keyword for this method only. So there is no problem. I will run the program. See the output. Try to observe the output. After 3 seconds, all operations are done. How these operations are done? Observe. Observe carefully. Observe carefully. Now, thread calling what? M1 method. Now, I'm marking step by step numbers. That is the order of program. What happened? This step, new deadlock will call. This will call what? This is the second number. Right? So now in this place, one main method is there, main thread is there. The moment it will call thread.start, what happened? This run method will be called by start.method. Then what happened? This will be fourth step. Now tell me T2.M1B. Where is M1B? Here is our M1B. Here is our M1B. This method will be called what it is expecting T1. It is expecting test T. Where is our test T? Test class object T1. What is T1? T1 means what? Nothing but test class object na. So this method will be called by whom? Child. Perfectly fine, right? Now this call will be done. So what happened? Here, observe. One more thing. M1A. Where is our M1A? Where is our M1A? This is our M1A. This is our M1A. So what is happening? The moment this is called by what? Main thread. This will be called by main thread. Okay? This will be called by main thread. So what is printing? Thread 1 calling M1A. This line is printing by main thread. When multi-threading concept is run, we know the which output will come. So that's why thread 1 is calling is printed. First part is done. Then what we are getting? M1B. Now child is getting opportunity. So that's what thread 2 calling M1B. Second line is printing. Okay? Now the code will reach here. Then who will sleep? Thread 2 will going to sleep now. Thread 2 means child. And this is thread 1. Think in this way. Okay? So those two lines are the moment it will sleep, which in this line, which thread is going to sleep? Thread 2 is going to sleep. Then thread 2 sleep means thread 1 is getting opportunity to work now. So it will complete its logic in even 1 nanosecond. But we are giving 300 millisecond, means 3 seconds is more than enough to complete the operation. So now the moment it will, this line thread, child thread will sleep. What will happen? The main thread is getting opportunity to run all its operation. Because child thread is going to sleep 3 seconds. Main thread can take 1 nanosecond also to complete the operation. That is how computers work. Now this thread is getting chance. Now try to observe. Now what is our output? This is our third output. It means main thread. Thread 1 calling. This line is going to print. Okay? Now what is here? Test2.m2. M2 method is also there. But which object reference we are calling M2 method here? Test2. Where is our test2 M2 method? So that's the reason from here it is going to call this method. Hope you are understanding. That's the reason this line is printing inside M2 of test2 class. Perfectly fine. Now this call is done. Now thread 2 calling M2A. This operation is done now. This operation is done by thread. Main thread is done. Now sleep 3 after 3 seconds. What it will done? It will wake up. So control will go from here to here. Right? So what it will print? Thread 2 calling M2A. This line will print it. After this line printed, what we are calling? T2.m2. Again, M2 method is there, both sides. But which object reference we are calling? T belongs to whom? T belongs to this T. T means, small t means what? Small t means what? This test class object reference. So this method will be called. So from this method, this M2 method will be called and this line will be printed. Perfectly fine. Inside M2 method. All operation are done now. Till now, any deadlock condition? No. Now observe. I am clearing the drawing. I am using synchronized keyword. Observe, guys. I am using synchronized keyword. Now observe. I am using synchronized keyword. Now all the methods are synchronized. Means object lock is coming in the picture. Here also was object lock. Here also was object lock. Here is also object lock now. Here is object lock now. Means one lock is there unless and until that object will release the lock. Another thread is not able to do the operation. Okay? Let me take the screenshot of this so that this is without all synchronized method. Let me keep here in paint. I will keeping here this output. Then we will compare the another output. This time I am using synchronize at both 4 places. So now try to understand. Same thing is going to happen. Everything is same, only 1 or 2 places. Now this is our first part. This is our second part, right? This is called by main method. This is called by child method. Now here thread dot start will call what? Run method. Okay. Now t2 dot m1b. Where is m1b? This is our m1b. Try to observe, guys. Try to observe. M1b is called by child. Okay. Similarly, M1A is called by what? Main thread. There are 2 threads. One is here main thread, and here we are defining child thread. Now observe. Now the moment this line come, child thread will sleep. Child thread will sleep. Main thread will become active. Main thread will become active. But now observe. This method is synchronized. It means there is a lock of the object. Lock of the object na. The moment after this part thread dot sleep, main thread git will approach. Main thread will be in active mode. But the moment it will call test2.m2. Test2.m2. Where is M2? This is M2. But this is what synchronized this time. What will happen? What will happen? Try to observe. I am running the program. It is stopping here, right? Only 4 output. What is happening? What is happening in the complete program? What is happening? Try to observe. Try to observe. What is printing? Thread 1 calling. See, thread 1 calling. Thread 1 calling. This line is printed. Let me change the color. This line is printed. Thread 1 calling something. So this is our first output. Now, thread 2 calling M1B. Thread 2 calling M1B. Till now, this is our second output. Because before coming into synchronize and slip, both the thread is running. Fine. The moment it is going to call thread 2 now try to observe. The moment child thread is sleeping or here, what is our third output? Thread 2 calling M2A. Thread 2 calling M2A. This line is running. This is also fine. Thread 1 is calling. That is also fine. But the moment it reached to this part, the moment it reached to t.m2 and test2.m2, they're calling, they're synchronized na. They are synchronized. What is happening in this situation? Both are synchronized. So here, in this place, thread child is giving chance to whom? Main thread. The main thread trying to call this, but who locked the object? Who locked this? Where is method M2 is available? In test2 class object, which is locked by child thread. So it will wait. So this thread will wait. This thread will wait. Same thing. In waiting state. Now, when this t.m2 will look for this method, this is also locked by whom? Test object. So this thread also in waiting state. Do you think this output is coming here? No output is coming. Both are in waiting state. Both will wait for lifetime. It will not. See, did my server this my JVM stop? It is in red. Red color means it is still running. It is still running. They are in waiting state. See this red symbol. It is running. Red state. It will once this will be stopped. Now observe. I am removing all the drawing. I will remove the synchronize keyword. Then you will find the difference. Now I am stopping this here. I am stopping here. Now in red button I am stopping. I stop. I kill the process. Now this synchronize. When this process will be completed, automatically you will get all the output. This red button red is there. Automatically this red will become disabled, right? All is running. When I am using synchronized keyword, observe this red button. What does this mean by red button? They are in waiting state. That's why this is coming as red. Now observe this red button. It is always red. When I am removing what? When I am removing synchronized, I am stopping again. I am removing this synchronize. Now I am running this program. Now observe this red button. Red button, all the output will, the program terminated after a successful turn. Understand deadlock condition? Understand deadlock condition or not? You can now talk to me, guys. Did you understand deadlock condition? Who is the reason? What is the reason for deadlock condition?
Synchronize.
Synchronize keyword is the reason for deadlock condition. Synchronize is the reason for deadlock condition. I will share this program with you in the chat, this screenshot. Then you will understand. Hope you understand also, but I will give this program as well. Okay, now. So synchronized keyword is there, which is which may cause what? Deadlock condition. So whenever we are using see, compilation there, no problem is there. Only we know the concept, then only we understand the other side of synchronized keyword. If you don't know this concept, then what will happen? Then we are not able to understand why our output is not coming. So whenever such waiting state is there, but and synchronized keyword, then you have to think about this concept. Okay, now. Condition. Now new concept is Deamon thread. Now Deamon thread. What do you mean by Deamon thread? Deamon thread. Yeah. Now Deamon thread. What do you mean by Deamon thread? Deamon threads means some threads, some code, some logic is running in background. the threads which are running in the background, are called daemon thread, are called daemon thread. What is the purpose? Purpose is to provide support for non-daemon threads like main thread. Right? This is the benefit of daemon thread. Daemon thread will support main thread. Okay? Now. Now we will see one program also for this. But before this, let's say what is garbage collector also? Garbage collector. So what is daemon thread? Daemon threads are running in background. So they are supporting main thread. What are main thread? What is the priority of main thread? 5. There are from thread wise. What is the priority number? 0 to 10. You know, right? Main thread primary priority number is what? 5. So what is the purpose of main thread? To provide support in background. Some system are running, right? when we are running the program, how main thread is running, how garbage collector is running. Are we asking, hey, garbage collector, go and clean up the memory? No. What is the garbage collector? Whenever the program runs with the low memory, JVM will execute garbage collector to provide cleanup activity, right? So there is a daemon method. There is a daemon method. We will see that in programmatically. Then garbage collector will be called by JVM. Okay. Then it will clean up what? Unused object. Unused object. Right? So there is a method. There is a method. Is daemon. Is daemon. Is daemon. Is daemon is the method. Okay. By this we can able to understand whether the thread is daemon or not. Whether the thread is daemon or not. Okay. If daemon type is what type? Boolean. Means if it is true, we get the output by calling this method, then that is daemon thread. If false, it is not daemon thread. Okay? Now, let me take one program. Okay? Okay, let me copy this. I will share this program with you guys. Okay? And let me take the screenshot itself now. 1 minute, I'm stopping my screen share. I will share this in sharing right now. Otherwise, Java Techies channel without synchronized keyword. With synchronized keyword, and I pasted both the program. Now let me share the code also. Hope everyone received that code. Okay, in the channel. Now again, I'm sharing my screen. Again, screen. Okay. Everyone received the program, right?
No, sir.
Guys, I am. You did not receive the channel?
No, on you shared on chat.
Yes, I shared over the chat now.
We didn't get.
Coder in your Java techie.
Yes, please.
You received, right?
Yes.
Yeah.
Sir,
Because that is
where you said, sir? I check on chat.
one second. I'm sharing again. Observe this, whether you received or not. You have this. You have this channel, right?
Okay, means you
This
said that
channel.
on channel.
We have this many channels. Okay. In this channel, I'm saying. Okay. Now. Now, observe. Now you received the. Now we will write one program to understand Deamon thread. Okay. Now I am removing this logic. I'm this part also. Okay. I'm using main method. Main method. Main method is there, right? Now. Dot println system dot out dot println. ठीक है. Now, how to get current thread dot current thread, right? For example, simple. Run this program to know what is the current thread. Let me run this program. Okay. See, main thread is printing 5 and it is main, right? Current thread. Try to observe. Control Shift. Let go inside this method. Save this. What is printing? Try to observe. Current thread. Current thread is called, right? This is the method where the current thread is giving what? These are the priority we have seen in previous session. So not much explanation is required for this. So this is thread dot current thread. Thread is main and its priority is what? Now. Now. What is our method? Is Deamon. Is Deamon. Run this program. This is false. Main thread is not a daemon. Main thread is not a daemon. Now, let me create one my thread object. My, not my thread. Let me, okay, let me, okay. Let me create extends thread. Okay. I am extending thread class also. Okay. Now, it means I define one thread now. I define one thread. Now, I define one thread, so run method will be also there. Okay. I can call run method public void run method. Perfectly fine. No problem. How I can call this method? I need to create the object for this class, right? Because this time I'm extending thread class, not implementing. So I can create this object like this, right? First letter small. I can call what? I can set Deamon thread or I will change some condition. Now observe. This is void run. I am trying to print some logic. I am printing some logic here. For loop I am using for loop. Int x equal 0. Then int x is less than 5. Simple. And x plus plus is simple. And now I'm printing something. Now printing something. Let's say I'm printing something I will inside run method. ठीक है, inside run method. Now let me use thread.sleep. Thread.sleep. Are you understanding why we are using frequently thread.sleep? We are using thread.sleep means there will be, once we are having two thread, we are giving one opportunity to another thread for that particular duration. That's the reason I'm using thread.sleep. Hope you understand the why intentionally I'm using. When this thread.sleep will be called, so there will be two threads now. First is what? Main thread will be run by, main method will be called by main method. The moment I create this t.start something, right? So what will happen? Child thread will be created. So then what will happen when this will be created, called? So the child thread will sleep and some output we will try to find out. Some output we will get. That is what I am using always frequently thread.sleep. Right? Now. So now this is interrupted exception. Fine. Okay. Format this, select all, Control Shift F. Come here, main method. This is our main method. This is our main method. I have created. Let me copy. Paste here. And let me comment this line. It is not required. Now. Paste dot. Copy this. Child 3. I am doing set Deamon. Set Deamon. See, set Deamon. I am giving it is true. Now we will output. Now try to observe. What we are doing, we are creating one child thread. Okay. Then what we are doing set Deamon. Then what we will do thread dot start. Then it will call run method na? Dot start. Otherwise, without start method, how run method will call, right? Always keep this method. Start method will only call run method. Okay. Format this. Now, what is output? What is our output? We are keeping here thread as a daemon, right? Now, observe the output. Now observe. 1, 2, 3. Five times this method is run. 5 times this loop is run. Right? Loop is always after 3 seconds. It is printing inside run method. I have commented what? This line. I have commented this line. Now, what is this test deadlock, guys? It belongs to child thread, na? It is a child thread, na? Let me uncomment this. Let me run the program. It is terminated, right? It is terminated. Okay. So what is our observation? If we did not this line, what is happening? If we did not comment this line, main thread is non-daemon and child thread is daemon. I make child thread as daemon this time. But main thread is what? Non-daemon. Hence, what is our observation? Output did not came. So whenever main thread terminate automatically, child thread will be terminated. Very important observation. Very important observation. Let me note the point here, then you will focus. What is there? Main thread. Main thread is what? Non-daemon. Na? Main thread is what? Non-daemon. Okay? Now, I am making child thread as daemon. Na? child thread as Deamon. I am making as child thread as Deamon. In this line, let me call Control X. Paste here, my notes here. Main thread, non-Deamon. But by this line, what I am doing? Child thread as Deamon. Okay? So now, what is our observation? What is our observation? What is our observation? Main thread terminates automatically. Child terminates. That's why child thread terminated means this output is not coming. Let me uncomment this line. Let me comment this line. Now this is commented. Now let me run the program. Let me run the program. Now. Okay. So what is our observation? Both threads have to complete their operation. When I commented this line, main thread as well child thread become non-Deamon. Because main thread is what? Non-Deamon. But now, when I commenting, when I comment this line, comment this line, what will happen? Child thread become non-Deamon. Are you understanding? There are two threads. One is main thread, one is child thread. Main is always non-Deamon. And now child is also non-Deamon. So now both the thread, main thread will trigger child thread here in our logic. Main thread. Now we created object of our class, which is extending thread, means we started method, means child thread is running, and this program is running. Main thread already gone in dead state, but child thread is non-Deamon, so it is keep on running unless its operation is done. Right? Now, let me copy this line, paste here, uncomment this line, uncomment this line, uncomment this line. Let me add comment like this. Uncomment this line. Then what happened? Child thread will become Deamon thread. Right? Now this is Deamon thread, it becomes Deamon thread. But the thing consideration is what? Whenever main thread, automatically child thread terminate in this situation. So whenever I am running this program, automatically main thread terminated. So now child thread won't work because child thread become Deamon. So main thread depends on what? Main thread. Main thread down. If child thread are Deamon, also get terminated. Understand the program? Understand or not? You can talk to me now.
So Deamon thread means
Deamon thread means there are multiple threads running in background. For example, this thread we are running for our operations, but Deamon threads is like those code which is running in background, right? So what they are doing, they have some functionality. There are some functionality, right? So for example, there is one garbage collector. What is garbage collector? In simple, this program we are running, so it is utilizing some memory, na? Objects are creating in the background. Test deadlock object will be created. Inside object, some methods will be there, logic will be there, stored data will be there. Where it is storing? It is storing in memory. So, what is the purpose of garbage collector? Just garbage collector, I am telling you one example. What is happen whenever the program runs with low memory? What happen? PM is triggering what? Garbage collector. A garbage collector, do something and clean whatever the objects we don't require, clean up those objects. So it is cleaning up the memory in background. Something happening in the background, nothing but daemon threads. Those are daemon threads. Those logics are known as daemon thread. ठीक है? You are understanding what is meant by daemon thread?
Yes, yes.
ठीक है. And we cannot change main thread as non-daemon because it is always starting at very beginning. That's why we cannot change. Here, child thread, we can change the behavior, right? By changing set daemon true or false. By default, it is non-daemon. By line number 11, we make it what daemon by making it as a true. So child thread will become what daemon. No. You understand object class, right? You understand class. You know inheritance. Object, you know inheritance. Multi-threading. In multi-threading, we understand, come to know main thread, child thread, right? Who is the parent? Who is the parent of main thread? Various threads. One main thread is there, one child is thread there, 100 threads will be there. That concept we are going to see in advanced topic of multi-threading now. Before that, one concept is there. Deadlock versus starvation. If somebody will ask, what is starvation? Have you heard this starvation? Have you heard this starvation? Tell me. Did you heard this word starvation? No. Starvation is versus deadlock. You can consider one situation is deadlock, right? One situation is deadlock. What is mean by deadlock? Nobody is going to ask you this question in detail, but deadlock is somebody is asking. What is deadlock? Threads are waiting for each other. Lifetime. We have seen the synchronized keyword and program. Thread completely waiting. They are in waiting state only at particular till their lifetime. Unless and until we stop, they are still in waiting state. That is deadlock condition. And they are not going to end. Right? But the threads, the threads, the threads waiting for each other for some time, other for some, and then the process will end. In deadlock, they are keep on waiting. Is deadlock, but the same thread when stop after some time, that condition is starvation. That condition is starvation. Means the waiting thread will wait for some time, but at certain time they will what happen? They will end their waiting time. That is called starvation. ठीक है? What is race condition? What is this condition? Now I have taken one bank application, very first session of multi-threading, right? Karuna. I used the name Karuna. Karuna asked me that doubt that day. Now, in the same example, okay, in the same example, this is a bank application. This is a bank application. One thread is trying to update bank amount. Okay, in bank application, and one thread is trying to withdraw amount. Try to understand the example. One thread is trying to withdraw amount. Another thread is trying to update bank amount. Okay, and let's say not update, delete. Okay, delete bank account number, or let's say update operation. No problem. Now tell me, there is 5,000 rupees. There is 5,000 rupees. One thread, let's say T1. Okay. Another thread is T2. Another thread is T2. Another thread is T2. Okay. There is 5,000 rupees in the bank. What happened? This is one thread. This is another thread. If there won't be any lock in this object, for example, Karuna is trying to withdraw 5,000 rupees, then thread 2 should not act. It should be in waiting state. Okay, withdraw something amount, 1,000 rupees. Then after that operation, logic will be bank should have 4,000 in Karuna's account. Then second time someone is updating, then this update will perform in this operation. This is simple multi-threading. But at the same time, two threads are working. One is withdrawing, one is updating. One is withdrawing, one is updating. There may be change in bank amount in a wrong way, not in a positive way. In a wrong way, there may be chance. If multiple thread are working, logic is working on the same code, there may be some inconsistency na. That inconsistency is nothing but risk consist. That data inconsistency is nothing but race condition. So this can be resolved using what? Synchronized keyword. This can be resolved by which keyword? Already we have seen that program. This can be resolved by what? Synchronized data inconsistency problem can be resolved by synchronized keyword. But we should be very much careful. How to use, where to use synchronous keyword. That I explained very much because of this deadlock may come. Hope you are good with all this topic. Now our next topic is thread group. Very advanced topic of multi-threading. I don't know people are aware of this advanced multi-threading or not, but let me explain you advanced multi-threading concepts. This will be our topic. Very, very important. Multi-threading concept. What we are going to see in multi-threading concept? We are going to see thread group. You have heard, I explain you, every class, parent class is object class. Similarly, we have child thread, main thread, right? We are going to understand who is the parent of the thread, right? Everything we are going to see in advanced topic. Then we are having thread local. We have one concept, thread local. Okay? Then we have concurrency, very, very important. Concurrency concept. Then we have thread pools. Okay? Then we have interfaces, callable and future. People will ask you in this interview. Maybe they will ask this in interview. If you know this topic, 100% they will understand that you know the basic of multi-threading. Directly, there may be chance they will ask you advanced topic. What is callable? What is future? Right? What is concurrency? Not concurrency, nothing but executor framework only. That we are going to see. Next 3 days. Next 3 days. See, guys, there is no mandatory for this. There is no mandatory for me. I explain you multi-threading, but I want somebody is coming and learning this topic, they will take the benefit of this. I can skip this topic, but I before starting collection, I want to spend this 3 days maximum to explain you this. Okay? So we will see tomorrow this topic: thread group, thread local, concurrency, thread pools, callable, and future. This is the advanced one. Do you have any question, guys? I'm stopping my screen share. Just talk to me, guys. First, let me know.